feels weird to be coming back and doing some stuff with this paper, but I'm going to do this really quickly. This is the equation of the circle question. It's a relatively new question, so hence why I haven't really done it, because there wasn't many past exam paper questions for me to analyze. But I've got a few here. So I've taken all the times that they asked you on this circle equation question, which is kind of new, but it's basically a second part. I consider this a second part to the coordinate geometry exam hack series video. So make sure you watch that. I'll put a link of that in the description. Make sure you watch that first, because a lot of the material there and understanding is used within this question. So here, look, they're just asking you on circles basically. And I've gone through and extracted. They're all from 2020 because it's new. So you got all those and then all of my personal answers there. I went through and answered them all for you. So you can run through that and get a really good feel for what this question looks like and how they like to ask on circles. And now, what do you need to know? All you need to know is this. You need to know the equation of a circle. And the equation of a circle, just like the equation of anything, like a line, a curve. I mean, a circle is just a curve, right? It's just a really, really symmetrical, really nice curve that loops back in on itself. So this is the equation of a circle. It's x minus a squared plus y minus b squared equals r squared. That's the equation of a circle, just like y equals mx plus c, or something like that. You know, that's the equation, the general form of a line. This is the general form of a circle. I mean, it's just something different, where r is the radius of that circle and AB is the center of that circle. Meaning that if we want the equation of any circle, if we want that equation, we need the radius of that circle and the center of that circle. And from that, then we can find the equation of that circle. Just like for a line, when we need the equation of a line, we need the gradient of that line and a point on that line. Same sort of concept here. And maybe I'll prove that real quick before we do a question. And other than that, all you need to know is some really, I think, kind of, it does make these properties make sense, but maybe you will need to remember them. But some general properties of circles and chords and tangents and stuff like that, which you'll encounter when you go through the questions, what those are. But I've put a few of them here. So one of the things that you need to know is that a perpendicular bisector of any chord passes through the center of the circle. Sometimes they get you to use that, meaning that if you have any, okay, let's see how terrible my circle drawing is. Let's go. Okay, meaning if you have any chord, so AB, then the perpendicular bisector of that chord, meaning the line which passes through the midpoint of AB and is at a right angle to AB, so like this, a right angle, and that is the midpoint of AB, will pass through the center of the circle. You know, apologies for my drawing, but I just want you to get the idea. Okay, let's say another chord CD, chord just connecting these 2 points on the circle, on the circumference of the circle. Well, the perpendicular bisector will pass through will pass through the center. That's all that is. And there's sometimes they get you to use that. Another thing I think I put on there was equal distances. I mean, this just comes down to like, okay, so if AC is this just makes sense. I mean, if AC is the diameter, well then the distance between, and B is the center here, well then the distance between A and B in the X and then in the Y is the same as the distance between B and C. It's just another way of saying that this is, AB is half the diameter, or BC is half the diameter, and it's due to the symmetry of the circle and stuff like that. That makes sense. I mean, but you encounter that as well. And so yeah, I guess, okay, I'll prove this real quick. So this is the equation of our circle, x minus a squared plus y minus b squared equals r squared. So the two things you will need to find any equation of any circle is the center of that circle and the radius of that circle. Just like for a line, like I said before, the two things you need is the gradient of that line and a point on that line. So let's just really quickly prove this. And this is really follows on from the coordinate geometry question. Go watch that. It's a really good video in these kind of proofs, because I prove all that stuff there as well, like finding the midpoint, finding the length of a line, finding the gradient of a line, all that stuff. So let's say you have a circle with center AB. So I'm actually doing this proof off the cuff. I don't actually know. I'm pretty sure I know how to prove it. Okay. Oh my god, that circle is so bad. Okay, I'm gonna draw it again. Okay, come on. I got this. Come on, Jackie, you got this. I know I could use some circle drawing software or whatever, but I refuse to, man. This is real. This is how I would draw it. Okay, because you're gonna have to make sketches in your exam, sketches of circles, so you can get a visualization of what they're asking. Okay, and then let's say the points on the curve, we'll call them XY, right? So the point which defines this curve, this circle, you know, these are XY, right? They're changing along this thing. And then obviously the distance between the center and the point on the circumference is going to be R. So then how do we figure out how to represent this relationship for this circle or this curve or whatever, however you want to think about it? Well, the way that we do that, just like the way that we did for many of those proofs in the coordinate geometry exam hack video, we use Pythagoras' theorem. So we change this into a triangle. And this is just a way to prove it. I mean, this is just a way that I'm thinking about proving it. So this length here of this base, we could call that A, let's say, and B. And the reason to do that, because now we can get a relationship between sort of the circumference point and the center point, which is what this basically is, and the radius. So A squared plus B squared, this is Pythagoras' theorem, equals R squared, C squared. So what is A and B? Well, A is going to be this length. And what is this length? This length is going to be, well, X, you know, because this is X and this is A. So what is this distance, or this distance here? Oh my god. Sorry for this being messy. What is this distance here? Well, this distance here is just going to be X minus A. And same goes for up here. This is Y and this is B, so this distance is going to be Y minus B. So this distance here, you know, this height is Y minus B. So your A is X minus small a, and this is Y minus small b. It's R squared, and that's what you wanted. That's it. So that's the equation of a circle. That's really all you need to know. So that means that, let's say, for example, if you had, I don't know, x minus 1 squared plus y plus 2 squared equals 25. Well, what are the properties? What is the center of this circle and what is the radius of this circle? We'll put it into the form which you have here. You have x minus a plus y minus 2, because it's minus b. So this is minus 2 is the same as plus 2. So I'm just manipulating this formula so I can get it into this form, so I know it's the circle's properties, equals to 5 squared. You know, these two things are exactly the same. I just manipulated it. Because now I can see, okay, so our A is 1, our B is negative 2, and our R is 5. Okay, so that's the center and that's the radius. Okay, so I mean, that's just a little background. You should go prove that yourself to make sure you know this formula, because I'm pretty sure they don't give it to you, so you're gonna have to either remember it or just be able to prove it really quickly. Okay, so let's do a question. So there's lots of different things they can do here, but I mean, it mainly all comes from that formula. That formula is the fundamental content that you need to understand. So here we go. A. So we're given the coordinates, the points A and B. So A is at -1, -2, and B is at 7 and 4. Find the equation of the circle for which AB is the diameter. Okay, so we have some circle. So I would recommend always sketching these things out. So we have some circle, and we have a point, and this is not, I'm not drawing this perfectly. I'm just getting an idea in my head, getting my brain to see what's going on. B is 7, 4. Okay, and then so this it says this is the diameter, which means the midpoint between this will be the center, right? Because it says find the equation of circle C. Well, what do we need to find? So you could say to find equation of circle, we need it. We need the center and the radius, right? That's what we need to find this. Okay, so the center point will be at the midpoint between A and B because this is the diameter. And so then the radius will then, once we find the center, we can find the radius because it will be the distance AC or the distance CB. So let's find those things. So let's find the center. So the center is going to be at the midpoint of AB, which will be, this is this formula, y1. I proved that on my coordinate geometry video. So the center will be, well, A, so minus 1, x1, so this is your x1, y1, x2, y2. So x1 plus 7, so x1 plus x2, so plus 7 over 2. And y1 is minus 2 plus 4. Minus 2 plus 4 over 2. So that's 6 over 2, comma 2 over 2. So that's 1 and that's 3. So the center occurs at 3, 1. So let's say C, we'll call it C, is at 3, 1. You box that up because it's important. And then you want the radius. And we're finding both of these things because these things will give us the equation of the circle, which is what they want. Okay, so the radius is going to be the length AC. Or you could, even if you wanted to, you could say half the length AB. Maybe that makes more sense. So you know the diameter, I'm just going to say D. So the diameter is the length AB, right? So that means that the radius will be half AB, right? And what is the length AB? Well, this is the square root of, again from that coordinate geometry video, y1 squared plus x2, and I prove all this on that video. That's why I said you should probably watch that one first. Okay, so this is equal to a half of, well, y2, so y2 minus y1 is 4 minus 2. So half the square root of 4 minus 2 all squared plus x2 minus x1 is 7 minus 1. 7 minus 1 all squared, which equals to a half of the square root of, what is this, 6 squared plus 8 squared. 6 squared plus 8 squared, which is what? Square root of 100? 6 squared plus 8 squared, yep. So this equals to half of the square root of 100, which equals half of 10. More formally known as 5. So the radius is 5. Okay, so now that we have the center of the circle and the radius of the circle, we can now find the equation of this circle. So we can say, therefore, the equation of circle, this is going to be x minus a, which in this case is 3 squared, and plus y minus b, which is 1, equals to 5 squared, so r squared. So that's just from that formula I proved at the top. So therefore, this is the equation of our circle. Cool. B. Okay, B says find the equation of the tangent T to the circle at point B. Okay, so remember we have this circle B, we have A, we know all these. So it says that we have this tangent here, T. So this is the tangent line, and it wants the equation of that tangent line at the point B. So it wants the equation, it wants the equation of this tangent line. And if we want the equation of any line, we need the gradient of that line, and we need a point on that line. Okay, so we already have a point on that line, that's B, and B was B was 7, 4. This is 7, 4. And this is -1, -2. -1, -2. Okay? So we've already got a point. So the point, so split it up. So first thing we're finding is the point. So the point is B, which is 7, 4. And then 2, we want the gradient. So the gradient of the line, so we could call the gradient of MT. So the gradient of our tangent line, this is going to be to the negative reciprocal of the gradient of AB, right? Because this line is tangent, that means it'll be at a right angle to this diameter line. So we find, therefore, so we can find M of AB, and that comes from this formula, again, which I've already proved, and you should be super familiar with. So let's do that. So 4 minus 2, 4 minus 2 over x2 minus x1, so 7 minus 1. And that is equal to 6 over 8, which is equal to 2 over 3. 2 over 3? No. 3 over 4. Okay, so therefore the gradient of our tangent is the negative reciprocal of this, which is minus 4 over 3. Okay, cool. So now we have the gradient of that line and a point on that line. So therefore the equation of tangent will be from this thing, which I've also proved. So we plug in the point and the gradient, so we get y minus our y1, which is 4, equals to minus 4 over 3 of x minus 7. Cool. And so that's the equation of your tangent line. So I figured just doing one of these questions from the worksheet. If you guys have any questions from any of the other ones, please feel free to ask in the comments. Okay, C. But I was pretty rigorous with my written answers, so hopefully it's all explained. Okay, C. Find the equation of the circle which is reflected of C in the line T. Oh, okay. Okay, so you've got your first circle. So this is why I think it's important to draw these things out. And then you've got this line T, which you found. This is B. This is... Oh, where's my cursor gone? This is A. And then you've got this reflected circle. Oh my god, it's just going to be so badly drawn. But you get the idea. Okay, then you've got this reflected circle through T, and it wants you to find the equation of this reflected circle of C through the line T. Okay, so what do we need? So you might be like, well, how the hell do I do that? Well, what do you need to find the equation of any circle? You need the center of the circle, so we need the center, we call it C1, this is C. And you need the radius. So what is the radius of this new? We'll call C1. So the radius of C1 is going to be the same as the radius of C, of this first circle, right? Because it's a reflection. And the radius of our first one was 5. So that's that done. So the radius of this new circle is 5. And then what is C1? Well, this comes down to one of those properties, but just common understanding. Your C, so your C point is at, so the center is at 3, 1. 3, 1, and B is at, oh my god, B is at 7, 4. B is at 7, 4. So the distance, the x, we plus some x and we plus some y, will be the same as plus some x plus some y here. The same, they'll be the same. So to go from C to B will be the same as from going to B to C1, the other center, right? In both the x and y. So what do we do here? to get from C to go to B, we in the X direction we add 4. So we plus 4 in the X direction. This just makes sense, right? It's reflecting. It's the same distance. It's not being stretched or anything. It's reflecting. So the distance between there and that line, the reflective line, is the same as the center, that center to the line. I feel like I don't even need to write a property for that. Does that not just make sense? So then we plus, then how many in the Y direction? We plus 1 goes to 4 to get from, here to here. In the Y direction to get from C to this point B. So we get plus 3Y. 3 in the Y. Plus 3 in the Y direction. So that means to get from B to C1, we need to do the same. So that means that our C1 will be 7 plus 4 from the plus 4. So we're plussing 4 in this direction and then plussing 3 in the Y direction. So that means that it'll be then 4 plus 3. Okay, so that means that C1, our center point is 11, 7. And we did that because now we have the radius and the center point of this new thing. So therefore the equation will be x minus 11 squared plus y minus 7 squared equals 5 squared, which is 25. Cool. Okay, so yeah, it was a bit all over the shop maybe, but look, I did a question there, I went through it, but you've got all of the times that they asked on this circle equation question. I've extracted them all and I've answered them all there, so go through and do that. Yeah, good luck for your exams. Make sure you're being good to yourself, loving yourself, and you guys rock. Well done, and I'm sure you're going to do extremely well. I will see you in the next one.